junction diode. The another important application of semiconductor diode is rectifier circuits. So what is a rectifier circuit? A rectifier circuit is a circuit which rectifies AC voltage. By rectification we mean correction of errors or mistakes. Correction of errors or mistakes. This is the general meaning of rectification, correction of errors or mistake. When you rectify AC voltage, that is when you correct AC voltage, you get DC voltage. For example, if this is the AC input given to a rectifier, and after the process of rectification we have pulsating DC like this. This is the pulsating DC, and to overcome these pulses we use filter. In most of the electronic applications, DC voltage is required, that is constant voltage supply is required in most of the electronic applications. In our house, we have AC power supply because it is convenient to transmit AC power over long distances. So we have AC power in our house, but so many applications use DC power. So we have to rectify the AC power that we are having in our house to DC. And for this purpose, we use rectifier circuit. The next thing is stages of DC power supply. There are 5 blocks in this model. The first block is transformer, the second block is rectifier, the third block is filter, fourth block is voltage regulator, and the last block is load. AC supply is given to the transformer. AC supply is given to the transformer with rated frequency. In India and neighboring countries, rated frequency is equal to 50 Hz, and in USA the rated frequency is equal to 60 Hz. Transformer is used to bring level of AC voltage to desired value. If you want to increase the level of input AC voltage, then you can use a step-up transformer, and if you want to decrease the level of input AC voltage, then you can use a step-down transformer. So this transformer can be used as a step-up or a step-down. The next block is rectifier, and as I have already explained you, rectifier circuit is used to obtain the DC voltage. Once we have the rectification done to the AC voltage, the output of the rectifier will look something like this. Pulsating DC will be there. Filter is used to smoothen out the pulsating DC. This is the pulsating DC, and once we use the filter, we have the DC voltage like this without having any pulses. The next block is voltage regulator. This is very important. This is very important topic in analog electronics. It regulates the voltage level even if load changes. This is the load, and if we change the load and we are using the voltage regulator, then also the voltage will remain the same. Zener diodes are used as voltage regulator. This is the most important use of Zener diodes. They are used as voltage regulator. You may study the Zener diode as voltage regulator in the presentation I have given. You can follow the playlist and you will have the lecture in which I have explained how Zener diodes are used as voltage regulator. The last block is the load, across which we require the constant voltage supply. In this presentation and in coming presentations, we have to deal with rectifier circuits. We will use semiconductor diode in rectifier circuits. And we have to deal with 3 types of rectifier circuits. The first one is half wave rectifier circuit. The second one is full wave rectifier circuit. And there are 2 types of full wave rectifier circuit. We have 2 circuits by using which we can have full wave rectifier. The first one is center tap rectifier circuit. The second one is bridge type full wave rectifier circuit. So these are the 3 rectifier circuits which we have to cover in this course. In the next lecture, I will continue with half wave rectifier circuit, and in the coming presentations we will deal with center tap and bridge type rectifier circuits. We have to calculate different parameters in all the 3 types of rectifiers, and this is the most important part of this topic, calculation of different parameters. Everyone knows how these rectifiers work. they can easily relate how we are getting the output waveform, but the parameters, the derivation for the parameters, and also the final values of the parameters that will be directly used in numerical problems is something that you have to remember. I will derive these parameters for all the 3 rectifiers with clear explanation. I will end this lecture here. See you in the next one.